toward these. And then I have a lot of work to do this weekend for you. I have to make our reviews, to make our exam. I have to grade your last exams and email those back to you individually. So if you guys can just work on homework and studying and preparing, that'll be great. All right. So Stokes theorem, we have some learning objectives, and then we have the actual theorem. All right, so make sure you write that down. Okay. So says verifying Stokes theorem for a specific case. Verify that Stokes theorem is true for the vector field and the surface S, where S is the paraboloid. Assume the surface is outward orientated, and that Z is greater than or equal to 0. So the first thing you want to do is we have g of xy is equal to 4 minus x squared minus y squared. G of x is equal to negative 2x. Or not g of x. Apologies. You guys knew what I meant. Just a bit. Okay. And then negative 2y. So we're going to curl f. So we have I, J, A. All right. So the next piece, we have plenty of, slides. Don't worry. We all good. So what we're going to do next is by equation 619. Even if all of them needed an extra one, we have enough to do that. Curl F. We need more room. So, oh crap. Right. There we go. Oh, continued. So from -2 to 2, -8x, or 4 minus x squared, minus 2 square root of 4 minus x squared dx equals -4 pi. Okay, as a line integral, you can parameterize C by following. Why we're doing that. And it's going to be from 0 to 2 pi. Okay. We have Alright, so that's 0 to pi, 2 pi, sorry, minus 4 sine squared p dt. So you get -4 pi. Okay. Therefore, we have satisfied. Nope, verified, sorry, not satisfied. Verified Stokes theorem. Alright. Alright, this one says calculating a surface integral, calculate the surface integral where S is oriented downwards and F is the following. So we're just going to go straight into the situation. So using the steps, similar steps before, the curl of F is 1, 1, 2y. So by Stokes' theorem, okay, where C really hate that word. And then it's going to be from 0 to not including 2 pi. Which is interesting since we use it. So if it doesn't include 2 pi, how can they use it? But that's the way it's written. So now 0 to 2 pi, 1 minus cosine t, 0 sine t, negative sine t, dot sine t, 0 cosine t, dt. So then it's sorry, 2 pi. Yep, that's a 0. Also a 0. Second time I wrote theta instead of a 0. So then your answer ends up just being 0. Alright. Alright. Hopefully you guys can stick it out with me. We're super close note wise. Alright, let's just try to speed this up a little bit. So let's see. There's your information. To calculate the line integral directly, we would need to parameterize, hate that word, each side of the parallelogram separately, calculate 4 separate line integrals, and add the result. This is not overly complicated, but it is time consuming. By contrast, let's calculate the line integral using Stokes theorem. Let S denote the surface of the parallelogram. Note that S is the portion of the graph of z equals 1 minus x minus y for xy, varying over the rectangular region of the vertices. They give them to, well, it would be the x and y's only. So 0, 0, 1, 2, 0, and 2, 1 in the xy plane. Therefore, the parameterization of S would be x, y 1 minus x minus y. And it's going to be 0 to x to 2, and then 0 to y to 1. So then the curl of f is negative z 0x. So then Stokes' theorem says that we're gonna go from 0 to 2, 0 to 1. Sorry, I'm skipping the like not needed pieces. If you guys need the definition, feel free and write it out. Okay. All right, so we're good on that. Right. Happiness. So the rest of this, until we get to slide 10 or 11 now, is all just stuff that I think you should read from the text. So you can just look at the PDFs. I'm not gonna read them out to you. They're just really good examples, I think. If you've already read them because you know, worked ahead and you did what you needed to do, then cool. But this is why I think we'll be able to get this stuff done tonight. All right, so this says using Faraday's law, calculate the curl of the electric field E if the corresponding electric field is constant field. Should be an A there, is a constant field. BT equals 1 minus 4, 2. So since the magnetic field does not change with respect to time, negative equals 0 by Faraday's law, the curl of the electric field, oops, wow, cannot spell that for the life of me, is therefore also 0. Okay.